Hello, dear students. Very good afternoon to one and all. Good afternoon, Sakshi. Good afternoon, Jyoti, Rajnandani, Vandana, Sanika. Good afternoon to all of you. Can you able to hear my voice? Okay. So yesterday we have completed the D and F block elements lesson and we have revised that, right? So today we are going to solve the previous year's questions from NEET and JEE of this D and F block elements lesson. Got it? So all of you can able to recall and recollect the concepts which we have studied in this lesson, right? Shall we go for the questions? Yeah. So the first question for today is, which of the following statements are incorrect? So five statements are given to us and we have to find out the incorrect statement. So statement A says that all the transition metals except scandium form metal oxides, MO oxides, which are ionic. The highest oxidation number corresponding to the group number in transition metal oxides is attained in Se2O3 to Mn2O7. Basic character increases from V2O3 to V2O4 to V2O5. So, like this, five statements are given to us, right? So we have to find out the incorrect statement. So, all of you try to solve this question. I will give 1 minute to solve this question. All of you try to get the correct answer and let me know the answer in the chat box. Has anybody got the answer, students? Did you guys get the correct answer? Which of the following five statements are correct? Which option is correct? So what about statement A? Is that right or wrong? All the transition metals except scandium forms metal oxides which are ionic. Is that right or wrong? That statement is correct. Okay, that statement is correct. Next, coming to statement B, the highest oxidation number corresponding to the group number in transition metal oxide is attained in scandium to manganese oxide. So what is the group number for scandium? What is the group number for scandium? It is 3, right? Group number for scandium is, yeah, 3. Then for titanium, vanadium, chromium, and manganese. So what are the group numbers? 3, 4, 5, 6, and 7. Right? So these are the group numbers. And if you look into the oxidation state in oxides, in case of scandium, oxidation state of scandium is +3. And here it is +7. Okay. So the maximum oxidation state for scandium is +3. because the electronic configuration in case of scandium is 3d1 and 4s2. So we have 3 electrons. So those 3 electrons can be lost and scandium can have +3 oxidation state. And coming to titanium, titanium electronic configuration is 3d2, 4s2. So the highest oxidation state exhibited by titanium is +4. And for vanadium, it is 3d3, 4s2. So 5 electrons can be lost and +5 is the highest oxidation state. And for chromium, it is 3d5 and 4s1. So we have 6 electrons. So all the 6 electrons can be lost and it can take +6 oxidation state. Then coming to manganese, we have 3d5 and 4s2 configuration. So we have 7 electrons here. So we can have +7. So the group number corresponds to the oxidation, highest oxidation state of the particular element in their oxide. Okay, so that statement is also correct, and this is possible only from scandium till manganese. So from iron onwards, the highest oxidation number is not equal to the group number. So we have discussed this in the class, right? So early transition elements, they have the highest oxidation number corresponding to the number of electrons which is present in its outermost shells, and which is nothing but the group number. So option statement B is also correct. Statement B is also correct. Then coming to statement C, basic character increases from V2O3 to V2O4 to V2O5. Okay. So now all of you try to give me the oxidation state of vanadium in V2O3. What is the oxidation state of vanadium in V2O3? So we have 2 vanadium. So for each oxygen, we have to give -2. 3 into -2 is -6, which is equal to 0. So X will be equal to +3. Yes. So the oxidation state of vanadium here is +3. What about V2O4? In V2O4, what is the oxidation state of vanadium? In V2O4, what is the oxidation state of vanadium? Is it +3 in V2O4 also? Yeah, +4. The oxidation is +4. What about in R25? What is the oxidation state? What oxidation state in case of V2O5? It is +5. Okay, it is +5. Very good. So here you can see that oxidation number is increasing. So oxidation state is increasing. So if oxidation state increases, acidic character increases. Okay, acidic character increases. So this is what we have studied in the class. So what about the basic character? Basic character is opposite to acidic. So basic character decreases. So from +3 to +4 and from +4 to +5, the basic character decreases. But here they have said that the basic character increases from V2O3 to V245. So this statement is incorrect. The statement is incorrect. So statement C is incorrect. So means we have statement C only in option B and C. So either B or C should be the correct answer. Okay. So now let's try to find out the correct answer from these two. So go for D. Vaishnavi is saying B. So let's check whether B is the correct answer or not. So statement D is saying that the B2O dissolve has to give BO4 3 minus salts. Is that right? Is that right? It is not B2O4, it is B2O5. So B2O5 only dissolves in acids to give BO4 3 minus salts. Okay, so this statement is also incorrect. And CrO is basic, but Cr2O3 is amphoteric. CrO, the oxidation state of chromium here is +2. And then Cr2O3, the oxidation state of chromium is +3. The one which is having the lowest oxidation state is basic, and the one which is a little bit higher is amphoteric in nature. It is amphoteric in nature. So that statement is also correct. So the incorrect statements are C and B only. So option B is the correct answer. Vaishnavi, your answer is correct. Good. Students, can you all able to understand? So all these 5 statements are asked from NCERT book. Okay, it is the one of the neat question. Okay, all these are from the NCERT topic. Okay, got it? So any doubt for anyone? Everything is clear for all of you? What about for others? Anu, Jyoti, Chandana, Mahek, Rajrandani. Do you guys able to understand? Any doubt for you? Shall I go for the next question? Shall I go for the next question? Yes. Good. Here is the next question. In chromyl chloride, the oxidation state of chromium is. In chromyl chloride, the oxidation state of chromium is. So I'll give you the formula for chromyl chloride. So this is one of the JEE questions. So that's why we did not have options here. CrO2Cl2 is the chromyl chloride formula. All of you write and keep this in your notebook. Okay. So try to find out the oxidation state of chromium here and give me the correct answer in the chat box. Very easy question. +6. Sure. Anika is in +5. Okay, let's check. So here we have chromium. Take that chromium as X. So for each oxygen, we have to give -2. So 2 into -2 is -4. For each chlorine, we have to give -1. So 2 into -1 is -2, which is equal to 0. X is equal to +6. So the oxidation state of chromium in chromyl chloride is +6. The plus is already given there, no? So it is +6. Okay. Very easy question, right? Just we need to identify the chromyl chloride formula. That's it. Jyoti, it is not +2, my dear. It is +6. Got it? Shall we go for question number 3? Shall we go for question number 3? Yes. So here is question number 3. So two statements are given, assertion and reason. So assertion says that ionization enthalpy increases along each series of the transition element from left to right. However, small variations occur. The reason is there is corresponding increase in nuclear charge which accompanies the filling of electrons in the inner d orbital. So in the light of the above statement, choose the most appropriate answer from the options given below. So check whether assertion and reason are correct or not. What about the assertion, students? The assertion right? Assertion is right or it is wrong? Mahik is saying option C. Very good. Assertion is correct. So atomic size decreases across the period from left to right means ionization energy increases. So assertion is correct. So this is due to the increase in the nuclear charge. So if I have scandium, this is titanium, vanadium, chromium, manganese. So like this, the size decreases, ionization energy increases. So there is an increase in the nuclear charge. So we have nucleus at the center of each atom. So atomic number increases from left to right, means the charge which is present inside the nucleus also increases. Okay, number of protons, which is nothing but the nuclear charge, it is also getting increased. So the reason is also correct. And because of this increase in nuclear charge reason only, the ionization energy is increasing. Okay, so why ionization energy is increasing? Electrons are more closely attracted towards a nucleus. So the energy required to remove this particular electron will be very, very high on moving from left to right. So both A and R are correct, and R is the correct explanation of A. Okay, good. Most of you have given the correct answer for this question. Very good. So let's move on to question number 4. The total change in the oxidation state of manganese involved in the reaction of KMnO4 and potassium iodide in the acidic medium is. So you need to get the reaction, okay, of KMnO4 and potassium iodide in acidic medium. So we have studied this reaction in the KMnO4 topic. We have studied the compounds of transition elements, right? KMnO4 was one of the compound. It was the second compound we have discussed. And we have studied its oxidizing property in 3 forms: acidic medium, in basic medium, and in neutral medium. So this reaction comes in acidic medium. So can anyone guess the equation? So KMnO4 is reacting with potassium iodide, which is called as Ki in acidic medium, plus H plus. So what does it produce in acidic medium? It forms Mn2 plus salt and iodine. Very good. Iodine will come out. Very good, Vaishnavi. Iodine will come out and water will come out. Okay, so in acidic medium we have studied 5 electrons are gained. How many electrons? 5 electrons. So the oxidation state of manganese here is +7. So manganese is going from +7 to +2. So means how many electrons are gained? 5 electrons are gained. So only if you know the reaction, you can able to get the answer for this type of question. Okay, iodide is going from -1 to 0 here. So 5 electrons are gained by manganese. So here the answer is +5. Okay, we are asked to find out the oxidation state of manganese involved. So it is +5. Okay, clear? So kindly study all the reactions which are coming under each medium. Got it? Shall we go for the next question? Any doubt? Did you guys noted this equation down in your notebook? Okay. Question number 5. The stability of copper 2 plus is more than copper plus salt in aqueous solution due to the stability of copper 2 plus is more than copper plus salts in aqueous solution due to. What is the correct answer, my dear students? So here copper 2 plus is more stable than copper plus due to more negative hydration energy. We have studied this in standard electrode potential topic, right? So due to the more negative hydration energy, okay, because of this reason, copper 2 plus is highly stable in nature. Okay, so the answer is option B. Due to the more, if something is having more negative hydration energy, then that particular ion is more stable. The standard electrical topic, I have discussed this. Clear for all of you? Any doubt? Shall we go for the next question? Okay. The number of electrons involved in the reduction of permanganate to manganese dioxide in acidic medium is. The number of electrons involved in the reduction of permanganate to manganese dioxide in acidic medium is? How many number of electrons are involved in the reduction of permanganate to manganese dioxide in acidic medium? So again, we need to write the equation. So again, it is an equation which converts permanganate to manganese dioxide. So permanganate means again it is KMnO4. In acidic medium means it is H plus. So manganese dioxide, it is converted to manganese dioxide. So MnO2 is nothing but manganese dioxide, and in acidic medium water will come out. Okay, this is the equation. So what is the oxidation state of manganese in the reactant side? Oxidation state of manganese here is +7. And what is the oxidation state of manganese here? It is +4. So how many electrons are gained? All of you can able to identify why manganese is having +4 oxidation state here, right? So we have to take X and -4 equal to 0. So for each oxygen -2. So X is equal to +4. Okay. So +7 to +4. So 3 electrons are gained. How many electrons are gained? 3 electrons are gained. So in acidic medium, 3 electrons are gained by manganese to get converted to manganese dioxide. Okay, clear? Shall we go for the next question? Any doubt for anyone? Okay. Given below are two statements. Statement 1 is Cr2 plus is oxidizing and Mn3 plus is reducing in nature. Statement 2 says cadmium 3 plus compounds are repelled by the applied magnetic field. So what do you guys say about this? Statement 1 is correct or incorrect? Statement 1 is correct or incorrect? Tell me whether Cr2 plus is oxidizing in nature or reducing in nature. Cr2 plus is oxidizing in nature or reducing in nature. So oxidizing in the sense. So what is the configuration of chromium? Chromium configuration is 3d5 and 4s1. Okay. So if chromium loses 2 electrons, so we will have 3d4 and 4s0. So we have coordination compounds lesson. So in that lesson, we will discuss that all the 5d orbitals will get split. Okay, above 2 and below 3. So if I fill the electrons here, I will get 3 electrons. So 3 electrons are half filled here. 3 electron means it is half filled. So what this chromium 2 plus will do, since it has 4 electrons in a 2 plus state, it will lose one of its electron and try to be in chromium 3 plus state. 3 plus means the configuration will become 3d3, 4 is 0. So 3d3 is here. This is 3d3 configuration, which is half filled, and half filled configurations are more stable. Okay. So Cr2 plus is not oxidizing. Cr2 plus is reducing in nature. Cr2 plus is reducing. Okay, it is getting oxidized by reducing the other element. Okay, from 2 plus to 3 plus it is going right. It is getting oxidized itself by reducing the other elements. So Cr2 plus is reducing in nature. Then when you look for manganese 3 plus, manganese configuration is 3d5 and 4s2. Manganese 3 plus means how many electrons are lost? 3 electrons are lost. So again we'll have 3d4 and 4 is 0. 3d4 and 4 is 0. So we have 3d4 electrons again. So what this manganese will do, it will try to keep itself in manganese 2 plus configuration. Configuration for manganese 2 plus is 3d5 and 4 is 0. Manganese 2 plus means we have 5 electrons. 5 electron means it is half filled. If I put 2 electrons here, it is half filled everywhere. So manganese 2 plus is more stable compared to manganese 3 plus. So what this manganese will do? Manganese 3 plus will be oxidizing in nature. Manganese 3 plus is oxidizing in nature, whereas chromium 2 plus is reducing in nature. So the other way around is given for this. So statement 1 is incorrect. Statement 1 is incorrect. So when you go for statement 2, scandium 3 plus compounds are repelled. So what is the configuration for scandium? It is 3d1 and 4s2. Scandium 3 plus means all the 3 electrons has to be removed. Okay. So we will have 3d0 and 4s0 configuration. So we have 3d0. So no electrons are present in d orbital. So if no electrons are present in d orbital, then what is the magnetic character? It is diamagnetic in nature. If something is diamagnetic in nature, it will be repelled by the magnetic field. It will not get attracted towards the magnetic field. They will get repelled by the magnetic. Okay. So statement 2 is correct. Statement 1 is incorrect. So option A is the correct answer. Clear for all of you? Yes, Sakshi. Option A is the correct answer. Now able to understand the explanation which I gave you for these two statements? Do any of you have doubts? Okay. So we'll go for question number 8. We'll go for question number 8. How many of the following metal ions have similar value of spin-only magnetic moment in gaseous state? So we have atomic number for all the 4 elements and we have their ionic form. We have to find out the similar value spin-only magnetic moment value for these 4 ions. How many ions are having the same spin-only magnetic moment value? So go for finding out the mu value for each ion. So for first one is vanadium. Vanadium configuration is 3d3 and 4s2. So here we have vanadium 3 plus. Vanadium 3 plus means we have to remove 3 electrons from here. So vanadium 3 plus configuration will be 3d2 and 4s0. So how many unpaired electrons we have here? So these are the d orbitals 1 and 2. So how many electrons? N value is equal to 2. Okay. And what about chromium? Chromium 3 plus. Chromium configuration is 3d5 and 4s2. If I remove 3 electrons from it, I will have 3d3. So 3d3 means N value is equal to 3. Then when I go for iron, iron 2 plus. What is the configuration for iron? 3d6 and 4s2. Iron 2 plus means 3d6 and 4s0. So how many unpaired electrons are present? How many unpaired electrons are present in 3d6? So these are the 5d orbital 1, 2, 3, 4, 5, 6. So we have 4. N value is equal to 4. And when you go for nickel 3 plus, nickel configuration is 3d8 and 4s2. If it loses 3 electrons, we will have 3d7 and 4s0. So 3d7 and 4s0 means 1, 2, 3, 4, 5, 6, 7. So how many unpaired electrons we have? N is equal to 3. So chromium 3 plus and nickel 3 plus. These two elements are having same number of unpaired electrons. So the mu value will be same. So what is the mu value? Mu is equal to root of N into N plus 2 Bohr magneton, right? So N value is 3. 3 into 3 plus 2. 3 plus 2 is 5 and 5 3s are 15. So mu value is same for chromium 3 plus and nickel 3 plus. So the how many metal ions have similar value? Two metal ions have similar value of mu, spin only magnetic. Okay. Mahek, your answer is absolutely correct. Very good. Students, this type of questions are very easy, no? Able to understand? Yes. Shall I go for the next question? Or anybody is copying? Okay, I'll go for next question. The incorrect statement among the following is. Find out the answer. The incorrect statement among the following is. So yesterday only I have discussed about. Yesterday we have discussed the physical properties of actinoids, right? And the day before that we have discussed about the lanthanoids properties also. So try to compare those two and find out the correct answer. Has anyone got the answer? Very easy question it is. Which option is correct? A, B, C, or D? D. Some Jyoti is saying A, Vaishnavi is saying D. What about others? What about others? Actinoids are highly reactive metals when they are finely divided. That statement is correct. Yesterday we have discussed, no? I have also shown you the picture of thorium, right? I have shown the picture of thorium, and that thorium was finely divided into the powder. And I told you that if the actinide metals are finely divided, then they are highly reactive in nature. So statement A is correct. We are asked to find out the incorrect statement. Okay, go for B. Actinide contraction is greater for element to element than lanthanoid contraction. So this is also correct because the poor shielding, the poor because of the poor shielding of 5f electrons compared to 4f electrons, actinide contraction is greater than lanthanoid contraction. So this statement is also correct. Option C says that most of the trivalent lanthanoid ions are colorless in solid state. No, it is wrong. So most of the lanthanoid 3 plus, they are colored. They are colored. Why they are colored? Due to the presence of which electron? Due to the presence of F electron. Due to the presence of F electrons, FF transition will occur and they are colored. But here they are saying most of the elements are colorless in solid state. So that is the incorrect statement, which is the correct answer for this question. Okay. Lanthanides are good conductors of heat and electricity. That is correct only. We have discussed this statement also in the characteristics. Remember, lanthanides are metals. Metals are the good conductors of heat and electricity. So option C is the correct answer. Clear for all of you? Any more doubt? If you want to note down any of the points from the slide, you can note it down. Please don't unmute yourself. Listen until you are going to answer for the questions. Okay. So we'll go for the next question. The number of terminal oxygen atoms present in the product B from the following reaction is. The number of terminal oxygen atoms present in product B obtained from the following reaction is. So can you able to guess what which reaction it is? So what is the name of this compound FeCr2O4? What is the name of FeCr2O4? Very good, Sakshi. It is chromite ore. It is chromite ore which is used to prepare the potassium dichromate. Yeah, very good, Mahik. So this is the first step in that preparation. So chromite ore is treated with sodium carbonate and in presence of oxygen, it produces A. What is that A? What is the first step? Conversion of chromite ore to sodium chromate, right? So the formula for sodium chromate is Na2CrO4. So this is sodium chromate. And this compound A, sodium chromate, it is treated with acid. So this is the second step. And it gives out B. So the conversion of, what is the second step? The conversion of sodium chromate to sodium dichromate is the second step. So what is the formula for sodium dichromate? Na2Cr2O7 plus H2O and Na plus. Okay. So what is this? This is called as sodium dichromate. So here I have Cr2O7 2 minus ion and Na plus ion. Okay. So this is the dichromate ion. So here we have to find out the number of terminal oxygen atoms present. So write the structure of Cr2O7 2 minus. This is dichromate. So draw the structure of dichromate ion. So we have two chromium and one of the oxygen is bridged and we have 6 oxygens here with O minus and here also we have 6 oxygen. Cr2O7 2 minus. So can you all able to find out how many terminal oxygens are present here in this compound B? Terminal means the end, the oxygen which is present at the edge or the end, terminal oxygen. How many terminal oxygens are there? 1, 2, 3, 4, 5 and 6. Very good. So we have 6 terminal oxygen atoms. And what about this oxygen? This oxygen is called as internal oxygen. It is present in the middle, no? So it is called as internal oxygen. The other 6 oxygen atoms are called as terminal oxygen atoms. Okay, clear? Shall we go for the next question? So you need to know the reaction first. So by knowing the reaction only, we can find out the product B first. And after finding out that product B, we have to draw the structure. So drawing the structure is also the major part here. You should know the structure also. We have studied everything in the class. We have studied the reactions. We have studied the structure. Okay, everything I have discussed with you in the class. So try to apply all those concepts which we have studied into the question. So, which is nothing but your competitive examination. Applying all the concepts which we have studied. Okay, application oriented questions like this will be more in all your competitive examinations. So try to apply all the things. Okay, instead of simply memorizing all those reactions, you should be able to apply those concepts. Fine. So I'll go for next question. Zirconium and hafnium have similar atomic and ionic radii because of why these two elements are having similar atomic and ionic radii? Any idea for anyone? Zirconium is an 4D series. Okay, 4D element. and this hafnium is the 5D element. So on moving down the group, we have 3D, 4D, and 5D, right? 3D will be smaller in size, and 4D will be little bit bigger, and 5D should be little bit bigger. But these two elements are having similar size because they belong to the same group. No, option B is not correct. What is the correct answer? Option D. Very good. Because of lanthanoid contraction. So what? Because of lanthanoid contraction, these two elements are having similar atomic and ionic radii. Okay. So because 5D series is this hafnium and 4D element is zirconium. So before this hafnium, if you see, we have lanthanoids. We have lanthanoids. Okay. So for all the lanthanoids, the shielding will be very, very poor. There will be poor shielding of 4f electrons will be present there for lanthanoids. Okay. So nucleus will be at the center. We have shell number 1, shell number 2, shell number 3, shell number 4, and shell number 5, and shell number 6. For lanthanoid, the configuration is 4f, 5d, and 6s, right? Suppose the last electron for all the lanthanoids will go into the 4f orbital. So let me take this. Okay. So all the electrons are occupying the 4f orbitals like this. And we do have electrons in 5d also and 6s also. Okay. So these electrons which are present in 4f, they do not shield properly. They have poor shielding effect. 4f electrons have poor shielding effect. So what happens? There will be some gap in between here, no? So the last electron will get attracted towards the nucleus more effectively. So if the last electron gets attracted towards the nucleus more effectively because of this poor shielding, what will happen to the size? The last electron is getting attracted, means the contraction in size will happen. Okay, contraction, the size will happen. So the size will be more or less similar for both 4D and 5D elements. So zirconium and hafnium will have similar radii due to this lanthanoid contraction. Okay, so this process is called as lanthanoid contraction. Clear? Clear for all of you? Yes. So we'll go for one more question. An acidified manganese solution undergoes disproportionation reaction. The magnetic moment value of the product having manganese in higher oxidation status. Acidified manganese solution undergoes disproportionation reaction. So disproportionation means single element having two different oxidation state in their product. I will give you that reaction. So manganate means it is MnO42 minus. So this is manganate. Acidified solution means it is treated with H plus. Sorry, it is H plus. It is H plus. Okay, when it reacts with H plus, it forms permanganate MnO4 minus plus MnO2 plus water. Okay, clear? This is the reaction. So here in the reactant side, what is the oxidation state of manganese in reactant? What is the oxidation state of manganese here in manganate? It is +6, right? Oxidation state is +6. Very good. What about here in product side? In MnO4 minus, this is permanganate, no? What is oxidation state of manganese in permanganate? Very good. It is +7. What about here in manganese dioxide? In manganese dioxide, what is the oxidation state? Very good. It is +4. So single element manganese is having two different oxidation state in the product. So in which one is getting oxidized. So this is the oxidized thing. And the other one, the other compound, the manganese is getting reduced. Okay. So we have to find out the spin-only magnetic moment value of the product. We have two products. We have to look for the product which is having manganese in their highest oxidation state. So which compound is having the manganese in highest oxidation state? First compound or second compound? +7 is the highest oxidation state containing compound, no? So we have to find out the spin-only magnetic moment for this compound. So we know that the manganese oxidation state electronic configuration is 3d5 and 4s2. Now here in this compound manganese is in +7 oxidation state. So all the 7 electrons are lost. So 3d 0 and 4 is 0. So we do not have unpaired electron. So n is equal to 0. If n is equal to 0, what is mu value? Mu is nothing but root of n into n plus 2. So 0 into 0 plus 2. So mu value is equal to 0. Mu value is equal to 0. So oxidation, the spin only magnetic moment value is 0 Bohr magneton. Okay? Clear for all? Fine. So this is enough for today. Tomorrow we will discuss some more questions. Okay, I have some more questions for you. We will discuss the remaining questions in the tomorrow's class and then we can wrap it up. Got it? So any doubt for anyone? So is this session very useful for all of you guys? Do you have any doubts? Did you get something like how to approach the theory part which we have studied into the question in today's session? Yes. Okay, fine. Okay then. Thank you, students. Thank you so much. See you all in the next class. Take care. Thank you. Bye-bye.